Hello again, this is Mark Summers from Summers Technical Services. We're going to do a little preview about our weldment assignment, and I've given you this Solidworks assembly drawing, assembly model, all the parts, but I wanted to go through and kind of show you how I built them, and hopefully that'll help you to be able to figure out how to modify them to meet your particular size requirements that you were given. So let's get started. So first up here is the assembly drawing. So I've made these front, side, and bottom views so you can see all the pieces. I've labeled the A, B, C parameters that you'll be using to size your table on sheet 1 here, and then and you can change these drawings if you want to turn it into your own drawing. Just change the parameters accordingly, doing the changing the template parameters by going to File, Properties, and you can change all the parameters in the title block, and you can also change the revision history by just double clicking. This is dumb text up here. Same thing with the notes. This is smart text, I call it, and you get to that by going to File, Properties. So sheet 2 has a couple of views. I made these views so I could show all the welds. When you add your welds, you can use parametric features of SolidWorks to call out your 5 different welds and see them also here. Right now there's no welds shown because I'm going to put those in shortly. And then sheet 3 is probably the most important sheet because this is where we can do our cut list. And so this is the -1 weldment before the welds are added. The welds are added at the assembly level, so they're going to show up here in the -10 weldment assembly. But this is the weldment by itself, and this is where we build these structure, and we're able to leverage the toolbox inside SolidWorks to pull geometry for these A500 ASTM A500 tubes, and it does all these trimming and mitering all automatically to give you your cut list, which is what you're going to submit for the assignment. And so rather than having to do hand sketches and calculating dimensions, if you choose to use SolidWorks, it'll do that for you automatically, and we'll show you how to do that as well. So that's the drawing I gave you. If we go over to the assembly model, the -10, what I call the -10 assembly model, this consists of the weldment that we just looked at. That's the -01, and then we've got the tabletop. It's just a rectangular extrusion for the steel tabletop, and then the -5 part is the feet, or the feet at the bottom that I've defined on the assignment. And then I guess the last thing we should look at is, I guess that's it. And then the -1 is the weldment. And again, we're going to take advantage of a 3D sketch to show that. And let's just start that right now. So if you did this using regular SolidWorks, you could do it, and you could sketch and create every one of these individual tubes on its own part model, and then bring it into assembly model and then trim it. And it's kind of a pain in the neck because you can't see all the assembly at one time. You're having to build these individual sticks of tubes in individual part models, and then you pull it into an assembly and try to constrain them and put them all together. And it's just much easier to use this weldment functionality. And so let's see how we do that. So I started a new, we'll just use a rollback bar here. And the first thing I did was build a 3D sketch. And 3D sketches are a lot trickier than 2D sketches because you got a third dimension to deal with. And so we use constraints like along X, along Y, along Z to make sure these lines don't get out of plane, because on a 2D sketch, you don't have to worry about them getting out of plane because everything is in one plane. When you're doing 3D sketches, you're constantly having to worry about these things misbehaving and get out of plane. And so you can see these constraints here along Y. There's one along Z, and those are just related to the triad down here for the global coordinate system. So I've just made this 3D sketch, and I haven't defined the edges of the tubes or the inside edge of the tube. I've defined the center lines of the tubes, and that's going to be advantageous when we use our Weldments command here in a little bit. So it's just a stick figure, and you get an idea that these are the vertical legs. Here's the horizontal supports at the top, and these are these Schedule 40 pipes on these lateral supports. And I've just placed each one of these lateral supports at the center point, at the midpoint of these legs here. And so as you change the dimensions of these overall frame dimensions, these points here stay at the midpoint, and that's what I want you to do in your assignment, so that these you don't have to worry about changing dimensions. It always follows the midpoint. All right, so let's get out of that guy and see how I created this weldment. And so I'll use a rollback bar and come down here. Here's the first set at the top. And so what I did was came up here to Weldments and went to structural member and created a structural member. And so if I right click on this feature and edit it, you can see what I'm doing here. I've chosen those 3 edges to build my structural members, and I've defined it using standard parts inside of SolidWorks, standard extrusions. And so I chose ANSI inch, I chose square tube, wherever it is, square tube, and then I've got different choices for different sizes of tubes, and these are all built into the library inside of SolidWorks. And if there's sizes that aren't there, this is just a small subset, you can always add these to the library. And so I chose 4x4 by 1/4 inch for this top is what I assigned. I selected those guys there, and I can also change these corner treatments. And so I've chosen a mitered corner on these, but I can always come in here and click on these corners and change these corner treatments to a butt joint where one stops before the other, and I can choose the other option where the other one stops before the other. And for this case, I chose a mitered corner here to make a nice clean edge there. And so that created that first structural member group. And then I made the next one. I needed a different size tube, so these are 3x3s. And I did a similar thing. I went in and grabbed those 4 vertical parts of that 3D sketch and told it I wanted to do a 3x3 by 1/4 inch tube, and boom, I got it. Then what I needed to do was trim, because these tubes, let's roll this back here without the trim. These tubes go all the way to the intersection between these tubes, and so that was nice when I did my 3D sketch. I just defined these center line paths of all the tubes, but obviously I don't want this vertical tube to go all the way to the center line of the top 4x4 tubes. I want it to be trimmed back so that it stops at this surface right here. And so once I create the structural member themselves, I come back in here to Weldments and do the trim extend command, and end up trimming with this command. And I can edit this and show you what that looks like. And so I just tell it, hey, trim to this face here and discard the top piece that extends into this tube and keep the one that's below it. And so you have to keep track of which part you want to keep, which part you want to get rid of. And now these tubes are stopping where they need to stop, which is right at the base of these top tubes. And then we'll keep scrolling down here. Here's our Schedule 40 pipe. And again, I did the same kind of a thing. I just selected, I went to structural member, made new structural member, and I just selected these lines here so that it traced out, instead of using square tube, I use this pipe, ANSI pipe, and I use schedule 40 1.5 inch pipe. And it knows the size, the outer diameter, inner diameter, wall thickness. It knows all that stuff because it's built into SolidWorks. And I had a couple of groups. You can have multiple groups. I had one group, I think, were these guys here on the long side, and then group 2 was another group. I can't remember which is which. But anyway, you get the idea. You can have different groups because you might have different trims, and you might have different size tubes. And so these were both the same, and it created those tubes. And again, I had to go in and see, what is this? So this one is, so I made 2 different structural members. I made one group of the ones going long ways, and then this one was the other direction going on the ends here. And I just separated those because I thought I might want to keep them separate. And then I had to do a trim at the end to trim all these tubes because, again, these tubes, these Schedule 40 pipes are going to extend all the way to the center line of this guy, and I need to trim these back. And so I had another trim command, and each one of these trims to a different surface, and I grabbed all those surfaces. So here's the bodies to be trimmed. I selected all the tubes, and then down here I say this is what I want to trim it to, and you can use faces and planes, or you can use bodies. I use faces, and I selected these faces where I wanted these to trim to, and you can see the arrows are saying this is the side I'm going to keep, and the side that's on the keep side I say keep, and the side that's on the discard side on the inside of the tube I say discard. And you got to go through and select all those, and it takes a little while, but once you get it done, you get all your tubes trimmed. And so now if I look inside the bottom here, all these tubes are actually trimmed and stop right at that wall, which is, you can do these calculations by hand by using trigonometry on your hand sketches, but this just makes it a little automated. So that is the weldment. And so let's go toggle over and look at the assembly model. And so the assembly model, I pulled in the weldment, like I mentioned earlier, the tabletop plop on there, and just made it so you get your 2-inch overhang all the way around. And then the feeder on there. And so what I did was I put the top plane I defined as the floor, and so that represents the bottom surface. And so this first part I added, which was the weldment, I had to locate it using constraints such that, first thing obviously I put them so that the front plane and the front plane of the -1 lines up with the front plane of the assembly, and the right plane of the weldment lines up with the right plane of the assembly. And then the last one was I had to locate, since the top plane of the -01 weldment does not match up with the top plane of the floor down here. You can see the top plane of the weldment is where it is. But I had to have a distance offset to make sure that when I added these feet, I guess the weldment is at the bottom of the tube. I defined that as the top plane. For the weldment, the -01 weldment, the top plane is at the bottom of the tube, but I need to offset that because I want to have a space for a 1/2-inch plate here. And so that's what this constraint does here. It lines up the top plane of the weldment with the top plane of the assembly, but it gives me an offset so that this thing sits in the right spot. And so when you get through, what you're going to want to make sure you confirm is, when you go to evaluate, I've asked for the distance between the top surface of the table and the bottom surface of the floor, basically. And that dimension is the one I've assigned to you. In my case, it's 32 inches. In your case, it'll be whatever you've been assigned. And then the other dimensions are just the size of the tabletop. So in my case, it's 36 by 60. And that's not going to be the size of the 3D sketch, because you've got to have this 2-inch offset, and you got to have another 2-inch offset to get through the 4-inch tube to the middle. And so you have to calculate all that to figure out what your weldment 3D sketch looks like. And if I go back one more time and show this, this is the guy that has the dimensions for that weldment, and these numbers are not those ABC dimensions. They're different because you need to compensate for the thicknesses of the plate, the offsets, and all that stuff. Alright, so we've talked about the weldment, the drawing, the assembly. Now let's talk about the doing the welding. And so this is where it's really going to pay off here. And so let's do a weld down here. So I'd like to put a fillet weld, 1/4 inch fillet weld down here. And so what do? Well, we go to the assembly tab, and there's some assembly features here. And there's one called Weld Bead. And we can do several options. I can do the weld geometry. I can define faces that are intersecting. I can do a weld path that we'll show in a minute. Or I could just do smart weld. And I'm not that smart, but Solidworks is. And so I'll use a smart weld. Select it. And you just drag your mouse across the edge and choose tangent propagation, and it knows to weld all the way around. And I can define the weld symbol. I can tell it I want a all around 1/4 inch fillet weld. And I need this thing 4 places because I've got 4 different feet, and it puts a little representation of the weld in the model. But more importantly, it builds this weld symbol that I can show on the drawing later. And you'll do similar things with the weld for the top members. And so this thing's kind of in my way, so I'm going to hide this. And if I want to make a weld, I want to make my groove weld around that miter joint, then I will come in here and go back to my assembly tab, use the pull down here and go Weld Bead. And this time I'm going to say Weld Path. And I'm going to do, now I've got a blue box here to define the weld path. Well, it's just this guy and this guy. And I got to kind of walk my way around here. And go there. And there. And just keep working your way around. And so you can do all this. You can calculate all these weld lengths using your hand sketch and doing some trigonometry, but this is a little lazy man's way to do it. And here I come in here and I want this all the way around, and I want a groove weld. And then now I've got not only the call out, but I've got the little representation of the weld there. So I'll do that 4 times, and then there's a weld bead around here, another fillet weld. So I'll let you figure out how to do those. So you do all those welds, and then you can go show those in the drawing. So now that I've done that, let's go back. Let's close all this stuff out, and let's not save any of this stuff I've screwed up. And we'll go look at this drawing and see how we're going to do our cut list and things. Whoops, I screwed that up. Let's close this. This is going to open up a fresh copy here. Hopefully I didn't save any of that stuff I screwed up. Alright, so we got our tabletop back. Alright, so now let's talk about how to get these things to show up on our drawings. And so the first thing I'll show is how to show your welds. And hopefully my welds are still there. Let's open up the assembly model. -10. And yeah, I deleted all my welds. All right, let's go add a weld in here just so we can see what it looks like. So we'll go back to assembly, weld bead, smart weld, drag across there, tangent propagation, define weld symbol, fillet weld, 1/4 inch all around. All right. So now what I'll do is go back to the drawing, and now the drawing is not showing that weld yet because I haven't told it to show it. So the way to show the welds on the drawing is you come up here to model items. And model items is a way for you to pull data from your model. You've already worked hard to put it in the model. You don't want to have to add it again in the drawing. You just want to show it in the drawing from the model. And we're going to say I want to show the entire model. I want to import these items into a specific view, which say it's this view right here. And I want to turn on only this caterpillar thing. That's a caterpillar is just what it describes. That's the symbol that you show in a drawing to show that there's a weld there. And so in this view, I want to show all the caterpillars for all the welds I created from the model. And then I just say OK, and sure enough, they show up right there. So that's a caterpillar. And so that tells me that has that parametric weld in my drawing. And I can do the same thing for this view. And you'll do this after you do all your welds so that they all show up. But I've just got one weld in now, so that's all that showed up. So now I need to put my weld callout in my drawing. And so that's just as easy. I'm going to come to model items. And I'm going to find the button for weld callouts, weld symbols. And I want to say, I just want to put it in one particular view, which is this view. So I'm saying, look at the whole model, place weld symbols that are in the model in this drawing view. And I say, okay, and there it is. And so that's pretty nice. It's all parametric. If I don't like the way it's connected here, I can drag it around and connect it over here and drag it over here. It puts the symbols on there. It puts the weld all around symbol on there. If I want to put a note on here to define this as weld number 1 or something, I just double click on it. This is going into the model because this is a model thing. This is a model feature. This is made in the model. I'm just showing it in the drawing. And so if I want to edit it from the model, I could go back and open up the model and edit it there, but why bother? I'm just going to double click here. It's going to reach out into the model and find this note, and I can add a note that says, what is this, 4 places? Always use all caps. And then maybe I'll call this weld, I forget what it's called, weld 1, 2, 3, 4, whatever I did on the assignment. And that'll just add that to the note there, so you can reference it by a weld number, and it's 4 places because eventually you'll have it in all 4 places. All right, that's exciting. All right, now what do we need to talk about? Let's talk about the bomb and the balloons. And again, this is all, at this point, it's going to be just pushing a button. I mean, you've already done all the hard work. You've defined all the parts. You've added descriptions, and just ask for a bill of materials. So I'm going to come up here to the first sheet here. Tables, bill of materials. Just answer the questions. Select a drawing to specify the model for creating bill of materials. Well, any of these views will work. And it's got all kinds of options here that we can talk about if you got questions. But I just leave it on the defaults just for fun. And then I place the bill of materials. And it's got everything. It's got the part number. The part number comes from the file name. Those are automatic. It places the item numbers in the order in which I placed them in the assembly, and it automatically comes up with the quantities. The only thing I have to do here is change this font. This font looks goofy. I want it to look like the same font in my beautiful template down here. So I want to select the bomb, turn off use document font, and I got to manually go down here and look for Solidworks Roman D. That's the font I decided to use on my template, Solidworks Roman D. And now I've got the nice font to match the rest of my drawing. It wraps around here. I don't like that, so I'm going to drag that over. I don't like the fact that this is wrapping around, and so this is just too easy. I'm going to drag this over and make that one-liners, and that looks beautiful. And I can tag it over here. I can make this a little bit narrower, maybe get rid of number, maybe make this column a little narrower. I can change that to item, make that a little narrower, grab the button here, and whoops, drag it down to snap it right there. That looks pretty good. Maybe I want to drag it over. No, it looks good. All right, so that's it. All these descriptions come from the CAD models. It's the way it should be. It's parametric. You don't have to type this in twice. You've already defined that in the model. Under File Properties, you define the description in the part model, and it populates automatically based on my template I built for you. So that's pretty handy. Now if I want to add balloons, not surprising, it's just a button click. I find the balloon button. I'll click on item 1 and place it right there. And I don't want that quantity on there because there's only one of them. So I'll select that and make the quantity button or quantity option go away. Where is the quantity button? What's going on here? Should be a checkbox. There it is. Turn off quantity. So that's the tabletop. The weldment is down here, so I'll go back to balloon and place a balloon on the weldment anywhere. And on that's quantity 1 as well. These feet have quantity 4, so I'm going to turn on the quantity option, and hopefully when I check this guy here, it'll make that, if I can select it, it'll make that item 3 quantity 4. So that's my bill of materials for my top level assembly. I need 1 weldment, I need 1 tabletop, and I need 4 of those feet. Now we'll come over here. We already talked about that sheet, putting the weld callouts on there. You'll finish that up with all the different weld callouts. Here I want a cut list. And again, I could calculate these to find out the length of Ryerson tubing I need, or I can just push a button. I prefer to push a button. So under tables, I'll go to weldment cut list, and it's going to ask me what drawing view do I use to specify the cut list. Well, this is the whole thing here. And then there's lots of options down here. I'm just going to choose the defaults and say OK, and then I place the cut list, and boom, bam, it tells me each tube. It tells me how long it needs to be, and there's the 2 4-inch tubes. There's 2 here on the ends. There's 2 here on these ends. There's 3-inch tubes here, and there's those Schedule 40 pipes, and it calculates all these lengths for you automatically, which is kind of nice. So that takes care of that, and you can use these values in your spreadsheet you're building to come up with your costs and everything. And you can actually add columns to these cut lists, and you can define cost per foot, and it'll calculate all that out. But you can do that in Solidworks, or you can just build your little spreadsheet and pull these values over, and you can export this cut list as an Excel file if you want to. And this is all parametric. If you go into your model and change your 3D sketch on your -1 cut list, and or you change any of these welds, not surprising because that's the whole definition of parametric modeling, is the drawings update automatically. And so that's the advantage of using Solidworks for your manufacturing and industrial engineering designs. So I've rambled on long enough maybe. Hopefully that helps you understand the files that I gave you and how you can update those and use them to help you with the assignment to come up with the cost for building these tables. And if you have any questions, let me know. Otherwise, we'll see you in the next video. Make sure if you want to see these future videos to check the subscribe button and ring the bell so you get notified on new videos as they get posted. So thanks for watching, and we'll see you in the next video.